Okay, so in this video what we're going to do is look at, well, algebraic fractions really, but ones that particularly emphasize that need us to use the laws of indices. So I'm thinking of things rather like this. So you would have a number, a multiplier if you like, in front of a variable, and that would be raised to the power, let's say, m. Divided by, so you'll have a denominator, which again with a number, and the same variable but raised to a different index. So this is the type that we're going to be working with, and then we're going to extend these variables as well to make life more interesting, more complex. Okay, so let's start with something like this. So let's think of let's say 8 r to the, and let's use a negative index straight away, so minus 2, let's say, and use the fraction bar here. Now divided by 2 r to the minus 1. So 8r to the minus 2 divided by 2r to the minus 1. So we would generally start these sort of things by simplifying the numbers first. So we've got 8 divided by 2, which is going to give us 4. Next we look at the variables. So we've got r to the minus 2 divided by r to the minus 1. So that's going to be times r to the 1, because that minus 1 is going to invert the r to the minus 1 so that it joins this other r up in the numerator here. So we now have r simply to the plus 1. Okay, so now we've got everything on one line and we don't have any denominator anymore. We can begin to resolve this. So we can join these r's together by the first law of indices. So we just add the powers. So we've got r to the minus 2 plus 1, or 1 minus 2, gives us 4r to the minus 1, which is the same, just to finish, as 4 over r to the 1, or just 4 over r. Okay, so that's the first one done. Now what I want to do here is increase the complexity. So the idea with these sorts of things is that you make them really kind of knotted, and then the pleasure is in unknotting them and simplifying them. So we might have a question which says simplify, let's see, something like let's say 6e this time. Here's a different variable. 6e to the power of a third, so use a fractional index this time, divided by 3e to the minus, well, let's say 2/3. Okay, so how are we going to do that? Again, let's sort out those numbers first. So 6 divided by 3 is 2, and now we've got e to the third divided by e to the minus 2/3. So in other words, plus e to the 2/3, or simply, if we skip a step, just plus 2/3 here. So that very simply resolves to 2e to the 3/3, or e to the 1, which is just 2e. So our answer is 2e. Nice and straightforward, nice, satisfying, simple result. So let's try another one. What can we do now? Let's think of something, something like this. So if we have, let's say, 7g to the half, okay, divided by, let's just keep it straightforward, 14 g to the minus 5 over 2, like that. So a bit similar to what we had up here. But this time what we're going to do is make it slightly more complicated by bracketing the whole thing and raising it to the power, let's raise it to a negative index to the minus 3. So this is the sort of thing that really worries people when they look at it and think, well, this is really hard maths. But it's just a case of unraveling it to sort out what's going on here. Now, first of all, let's have a look at this negative index here. So we're going to sort that out first. We really want to resolve negatives. To simplify, we want to deal with the negative first. So this means the reciprocal. It means flipping it up the other way. It means 1 over. Or, in this case, the numerator becomes the denominator and the denominator becomes the numerator. So we can rewrite this, in other words, upside down. So now we've got 14g to the minus 5 halves divided by 7g to the half, all to the power 3 or cubed. And there we got rid of that negative in the index simply by inverting or flipping the numerator and the denominator. So that's the first step. Now, what we can do with the cubing is we can use this as a multiplier throughout. But before I'm going to do that, what I want to do, I think, is resolve the interior here. So we've got 14 divided by 7, which is going to give us 2. And we've got g to the minus 5 halves. And bringing this up to the top is going to give us a negative index. So we've now got g to the minus a half. So I can just write minus a half on the top here. And all of this will be cubed. So resolving inside the brackets first. So we've got 2g to the minus 5 halves minus a half. So it's minus 6 halves. So that's going to be minus 3. And again, all of this cubed gets us a much simpler expression. So it's beginning to sort itself out. Now, we can work with the number first. So cube the number will give us 2 cubed, which is 2 times 2 times 2. In other words, 8. And g to the minus 3, we simply, in this case, so the third law of indices, we simply multiply the 3 by the minus 3, and we get g to the minus 9. Now, g to the minus 9, we always want to simplify to finish without a negative index. So we now have 8 g over g to the 9. So our answer is 8 over g to the 9. Nice and straightforward, and a lovely kind of fractional expression to finish. Okay, I think we can do maybe 2 more. Let's have a look at something again that we can get our teeth into. So let's have something like this. This time let's have sort of slightly larger numbers, and we'll have x to the 2/3 and y, let's make this really interesting, minus 4/5. Okay, and put our fraction bar in. So we'll have 18 x squared y, again let's have something interesting at the bottom here, minus 9/5. So there we go. Something that looks horrendous and that we really dearly want to simplify. Let's see how we begin. Well, we've got no index controlling the whole overall thing, so it's really all to do with what's going on inside here. So we can say now 12 divided by 18. Well, 3 goes into 12 and 3 goes into 18, so 3 goes into, in fact 6 goes into 12 and 6 goes into 18. So we'll say that's 2/3 straight away. Now we've got x to the 2/3 minus this 2 here, but what I'm going to do is say that's minus 6/3, so changing my 2 to 6/3. And there we go, like that. Now to deal with the y's, we've got y minus 4/5, minus a minus, so plus our 9/5 here. And we're done. So all we've got to do is simplify this, so that becomes 2/3 of x. Now to the minus, well, we've got 2 minus 6/3, so we've got minus 4/3, and we'll have now minus 4 plus 9, so that's 5/5, which is just 1, so y to the 1 is just y. So we're nearly done, but we don't remember, we don't want to leave a negative index, so to fully simplify we must get rid of these negatives. So just to finish, we need to put the x back in the denominator position. So we have 2y in the numerator, and in the denominator we have 3x to the 4/3. So there we go. A nice simplified expression. And lastly, let's have something with 3 variables in the numerator and denominator. So if we have L, M and N, let's have L, let's just leave that for the moment, M, let's say cubed, N to the minus 1/4. And what I'm going to do this time is I'm going to just add a power to all of this. So let's raise that to the power 4. Okay. Put our fraction bar in, and underneath, what should we have? Let's say L to the minus 2. Let's just have M here. N to the half, square root of n if you wanted to express it like that. So that'll do for the denominator. Let's put it all in parentheses and again raise it to a power, but this time a negative power, so let's have minus 2. So there we go. There we go. There's the challenge we've set ourselves. And how are we going to deal with this? Well, I think when we've got the numerator here raised to the power of 4 and the denominator raised to a different power, when it's not a sort of overall raising to a single power, when we've got 2 powers here, I think what I want to do is, and it's not the only way of doing this, but I want to deal with the top and deal with the bottom separately. So what I'm going to do is multiply that 4 throughout the top and then multiply that minus 2 throughout the bottom using the third law of indices. Now there would be another way of doing it, and the other way of doing it I think would be I could deal with this negative first, which would be to bring the whole of the expression at the bottom in the denominator up to the top, and so you're just multiplying across, and then you could join the L's and the M's and the N's together. That's an alternative way of doing it. I'm going to do it this way. You might want to try it the other way as well. Anyway, let's just multiply across and see what happens if we do it that way. So we've got this 4 multiplying with L to the power 1 because there's an invisible 1 in there. So we'll have L to the power 1 times 4, L to the power 4. Our M is going to be 3 times 4, which is 12. Our N is going to be, interestingly, minus 1/4 times 4, so that'd be minus 4/4. In other words, it's going to be minus 1. And that's done the numerator. So now moving to the denominator, we've got L to the power, well, we've got minus 2 times minus 2, so that's simply 4, so L to the power 4. Just make it clear that's an L. M to the, well, we've got 1 here, so M to the minus 2, like that. And we've got N, half times minus 2 is going to be minus 1, so N to the minus 1. Well, that already looks much nicer. But now we need to simplify top and bottom so that we've just got everything on one line, everything in the numerator. So we've got L to the 4 divided by L to the 4, or L to the 4 minus 4. So let's write it out like that. L to the 4 minus 4. We've got M to the 12 minus minus 2, so it's 12 plus 2. And we've got N to the minus 1 minus minus 1, so plus 1. And I think you might be able to already see what's going to happen here. We've got L to the 4 minus 4, well that's 0, so it's L to the 0. We've got M to the 14, and we've got N. Well, minus 1 plus 1, same as 1 minus 1, is again N, is 0, so we've got N to the 0 here. And whenever we've got anything to the power 0, we can just replace it with 1. So we've got 1 times m to the 14 times 1. In other words, we've simply got m to the 14. Okay. Now in the second part, I just want to do two things. First of all, let's just summarize what we're doing here. Although there are different ways of solving things, and I'm going to come on to that in a moment, there is a kind of general procedure, and the very first thing is to sort out the ordinary numbers in these expressions, so this algebraic fraction that we've got here. So we can summarize this generally by saying, well, we're going to kind of join together the a and the b to create a fraction. So let's just represent that like this. Now what we've got to do is move, we generally want to move the denominator into the numerator, so we want to merge, if you like, the x terms and the y terms and any other terms that we've got here. So the variables all become 1, and so we're going to subtract the m from the n and the q from the p here. Now finally what might happen is that we get a negative out of this, so if n is greater than m, then we're going to get a negative index again, and we don't want to leave it as a negative index, so if it was that the x produces a negative index, then that x term would go back into the denominator to finish the problem. So we can see that that procedure being followed here when we worked through the C part in the first part of this video. So you can see here that we've got 7g to the half over 14g to the minus 5 halves. And what we did here was we gradually worked through this simplification until eventually we could merge the denominator with the numerator at this stage here. And then it was a case of simplifying until we got this expression here, and the final stage was again that we had a negative here when we finally multiplied out the indices here. We had a negative power, and so that moved the g back under the fraction bar to create 8 over g to the power 9. Now I think I mentioned as I've been going along that there are several ways of solving these problems. There isn't just one way of doing it, and that's one of the joys of working through problems like this, in fact. So I'm going to suggest that we work through this particular problem again, and the reason that you would do this, apart from the sort of fun of it to find different ways of doing it, is of course because we always want to check our results. Is this correct? You know, if we'd have done it a different way, then would we have got the same result? Okay, well, let's give it a go. So if I rewrite this like this, so instead this time of saying I'm going to deal with this negative first and take the reciprocal, in other words, flip it upside down, what if I just multiplied all the way through? So here I would have, well, first of all, I want to deal with these numbers, otherwise this is going to get rather ridiculous. So let's this time change 7 out of 14 to a half, and put that, raise that to the minus 3, and deal with these g variables separately. So we've got g to the half over g to the minus 5 halves, and all to the minus 3. So this is a slightly different way of thinking about the problem. So half to the minus 3, well, that would be 2 cubed. 2 cubed is 8, so we can resolve that one straight away. So let's just write 8 here. This one here then, we do now want to, well, we could do it again in two ways, but I think what we want to do, I tell you what, let's do it up and down, as it were. So let's keep that minus 3 for the moment outside the brackets, and inside the brackets take a half and subtract minus 5 over 2, so that would be adding 5 over 2, so that would give us 6 over 2, which is 3, to the minus 3. Now this is sort of similar to something we had up here, but it's significantly different, so let's see if it produces the same result. So now we've got 8, but we've got g3 to the power minus 3 this time, so multiplying through we get g to the minus 9, which does indeed give us the same as we had here, so we end up with the same result, 8 over g to the 9. So we say that this is correct. Let's have a look at another problem that we could rewrite. So here we had lm cubed n to the minus a quarter, all to the power 4 divided by this expression here. So let's just work this one through and see if we can do this a slightly different way. So again, instead of multiplying through, which is what we did here, to still have this numerator and denominator, what I'm going to do here is deal with this negative first. So if I write out the first expression exactly as we've got it here, so we have lm cubed n to the minus a quarter to the power 4, with the expression in the denominator, what I'm going to do is invert it, which means it comes up into the numerator straight away. So I open brackets, l to the minus 2, m, n to the power half, all squared this time. So that's removed that negative index. So now we just work our way through the problem. So we've got l to the 4. But what I'm going to do here is I've got in this bracket here l to the minus 2 times 2. So that would be our l to the minus 4. So I can write another l to the minus 4. Now going to considering my m's here, I've got m to the 12, and over here I've got m squared, so that's going to be times m squared, and now we've got n to the minus a quarter, so that's going to become n to the minus 1, and over here we've got n, just plain old n. So that's sort of gathered the terms together so I can see it nice and clearly. What we've got now then is L4 minus 4, so we've got L to the power 0, we've got M12 times M squared, which is M to the 14, and we've got our N minus 1 plus 1 there. So we've got again our N to the 0, confirming our answer of m to the 14.